Glad to see a bunch of folks here. I know it's close to lunchtime, so appreciate y'all coming here to the talk. We're going to be covering the Open Policy Agent, Intro and Deep Dive. I am Philip Conrad. I'm with the OPA project, and these are some of my fellow presenters. I'll let them introduce themselves.
I'm Rita Zhang, a software engineer at Microsoft and a maintainer of Gatekeeper.
Hey guys, I'm Jay Gabani. I'm also maintainer of Gatekeeper and software engineer at Microsoft.
Hi everyone, I am Tyler Schade. I am a software engineer at GEICO Insurance, and I'm a maintainer of OPA Envoy.
All right, let's get started. So the structure of this talk is we're going to have a quick introduction to OPA, and then I'll give some project updates for what's been happening in the last year, and then I'll hand it off to Tyler to talk about what's been happening with OPA Envoy, and we'll close with Gatekeeper updates from Jaydip. All right. So some of y'all may not know what the Open Policy Agent is, what it does. The Open Policy Agent is a CNCF graduated project. It's been graduated for about 4 years now. The project itself is about 10 years old, and it is what we call a general purpose policy engine. What's a policy engine? Policy in this context refers to the rules and conditions that govern how a piece of software behaves, and we use engine to describe a thing that takes inputs and generates outputs. In OPA's case, it generates decisions about things. So where is it used in the wild? Well, folks use it for Kubernetes admission controllers. They use it as validation steps in CI/CD pipelines. And a use case that's near and dear to my heart is using it for application authorization and IAM use cases. So why would you use OPA? Well, it allows you to take one of the nastiest types of problems when you're building an application and partition it off. You can deal with your policies separately from the life cycle of everything else you care about. If you have regulation changes, if suddenly you need to support user groups and unusual permissions, you can deal with that, and you can deal with it without having to change your application code significantly. There's also a good bit of tools and frameworks available, and the Open Policy Agent can generate audit logs as part of its normal operation. We'll see in a slide or two how the decision process works, and whenever a decision is generated, OPA is able to generate audit logs for that. There's also a good bit of tooling that's available now that wasn't available a few years ago. Things like the Regal linter make it a lot easier to write good code and make it easier for you to validate that things work the way you think they should. So here's a simple example of what OPA's process looks like when it's making decisions. We use the Rego domain-specific language to write our policies, and when the Open Policy Agent is working, it will accept inputs and use those to generate outputs, decisions in this case. So we can see in this example, we have a really simple RBAC policy. In this case, admins are allowed to do everything, and we default deny everybody else. This policy in the allow rule there, down at the bottom, looks through all of the roles that are provided in the input and looks to see, do any of them match up with the role admin? In this case, because the user Alice is an admin, Alice is allowed to do whatever it was they were trying to do. But in the case of Bob here, who only has the user role, we fall back to the default deny rule, and Bob is not allowed to take the action. This is very useful if you're building API authorization or trying to build a larger application. I know this is a toy example, but the process scales. One of the problems you probably noted in the previous slide is it seems a little simple, and we're trusting the input an awful lot. When you deploy the Open Policy Agent in the wild, you can provide trusted static configuration data with your policies. In this case, we have user role bindings there on the right, and that way we don't have to trust the input coming from the application over on the left. Inputs are always coming from outside of OPA, but the data document can be provided alongside your policies and is something that you can usually trust. So this is what a more realistic example looks like. The data blob you see at the bottom with our user role bindings and the policy both live on the Open Policy Agent instance. And when you get an input, in this case, we have something a little closer to a real-world example with a user action and object binding there. And this policy will look at both the input and the trusted configuration data we have and uses this to decide the user Alice, who we know has the role binding admin, seems trustworthy. Cool, we're going to let them do this. So this is a small example. Real-world policies look at a lot more properties often, but I think this is a good illustration of the basics. If you're interested in trying out the Open Policy Agent and seeing some somewhat more complex examples, some of which deal with Kubernetes and other technologies, I would recommend taking a look at the Rego Playground. It is at play.openpolicyagent.org. We have a little QR code for it there. And if you're interested in integrating it into your applications, there are a bunch of different SDKs and libraries available for a variety of different languages. Just this year, we had C#, TypeScript, and Java SDKs land. And recently, a policy evaluator landed in Swift, which is really cool. I think Microsoft has also been working on a Rust evaluator as well, which is really neat. So at this point, we will get into project updates, because over the last year, a lot of really cool things have been happening in OPA. So the current project version is 1.10. We have a roughly monthly release cadence, so it's about a 1-month difference between each of the different releases you see on this slide. You'll also note that we start here with 1.0. This year, we went from the v.0 numbering scheme to version 1. And as part of that, we also bumped the Rego language version up. We had a bunch of keywords that were things that you had to do, import future.keywords and all that. You don't have to do that anymore. Those keywords are now part of the language. They're baked in. They're expected. If you're refactoring policies from v0, there is a command, OPA format, which can help with auto-upgrading some of your stuff. The Regal linter also can be very helpful when you're upgrading older policies. So I could talk at length about just about anything on this slide, but I'm going to call out 3 of my favorite things that have landed in the last year that I think are really nice quality of life improvements or cool new features. Let's see here. So one of the neat things that has landed recently is you can now do parameterized testing in Rego. This allows you to write out larger sets of unit tests in a much cleaner and more sensible way than before. It used to be you had to have individual rules for every little thing, and this format is a lot nicer to work with when you want to have a battery of test cases for, say, the most important allow rule in your policies. Another thing that is near and dear to my heart is performance improvements. Over the last year, we've had a lot of them, and this is a really particularly cool one. So when the Open Policy Agent is running, you can configure it to generate so-called decision logs. This is the audit logging I mentioned earlier. And this includes a bunch of metadata about what went into making that particular decision. You'll get a unique ID for every single decision that's made. You'll have the input that went into making the decision and information about the requester, what rules were involved. If you're using bundles, you'll get the bundle version, and you also will get to see the output. This is really handy if you need to go back after the fact and understand, why did this decision get made that way? So decision logs are great, but they are in the critical path. When OPA is generating decisions, right, when it's servicing incoming requests, this becomes part of the hot path. And so the performance of decision logging is directly tied to the performance of OPA. How quickly can it service requests? How many requests can it handle? And so on. And so previously, we had a buffering scheme that prioritized fairly tight memory limits and on trying to send the most compact, best compressed possible packets upstream if you were sending your logs off to a remote source. This was great, but it could be very slow. It had a fair bit of locking and was kind of inflexible if it needed to drop events from a buffer, because it was aggressively trying to compress everything all the time. In the newer design that has landed, there's a new buffering scheme which you can set up in your configs called the event buffering scheme. You have a fixed size buffer of events, which may not be appropriate for all use cases, but for high performance OPA use cases, just figure out how big your buffer needs to be, and this is a vast improvement. Events are compressed just before being sent upstream. There's a lot less locking, a lot less allocation overhead, and it is a massive improvement. This was contributed just this year by some of the maintainers, and I think it's a very cool thing. This feature, one of my old coworkers actually worked on this. It is a bit of an experimental feature that landed. You can now compile Rego rules into SQL. Specifically, you can generate data filters. So if you have an application where you're already querying a database, but you might want to do a little bit of just-in-time filtering right before handing results back to the user, this is potentially a tool that allows you to do that with policy. We have support for a couple different ORMs. We can generate an intermediate conditions representation. And we can also just generate SQL where clauses, right? This isn't the whole SQL query. This is just the part that filters rows. This is a little bit of an advanced feature, so there are some sharp edges still. But if this is something you're interested in trying out and it fits your use case, let us know how it's working out for you and if you run into any issues. All right. If you are interested in learning more about OPA, or you want to learn more about some of the new features that have landed, I would encourage you to look at the OPA docs, which we have a link for on this page. And if you're using OPA in your work, we really want to hear from you, especially if you're having any issues. We want to know. And the OPA community survey here is one of the best ways to let us know. We do actually read every single entry, and we do use it to help decide what kinds of things should be prioritized on the roadmap in the coming year. All right. And with that, I will hand it off to Tyler.
Thanks, Philip. Hi, everyone. As I mentioned earlier, my name is Tyler Schade. I'm an engineer at GEICO Insurance, where I lead our hybrid cloud engineering org. I'm also one of the maintainers of OPA Envoy, but we're also end users of OPA Envoy at GEICO. So it's kind of fun to get to be on wearing both hats and see sort of how it gets made, help steer it, but also see how people I work with are using it. It's very rewarding. I'm excited to tell you a little bit about the project, what's happened over the last year, and then cover where we want to see the project grow in the year ahead. So what is OPA Envoy? If you haven't heard of OPA Envoy before, it's an official OPA org subproject to extend the open policy agent that you know and love already with an implementation of Envoy Proxy's external authorization protocol. It uses OPA's built-in plugin system to add a gRPC implementation of x.z from Envoy directly on top of OPA. And it's a really easy way to add transparent authorization to a service running behind an Envoy proxy, whether it's an API gateway, a service mesh, or just Envoy itself. It's very common to run it in Kubernetes as a sidecar, but it can also be run centrally. It can be run directly alongside anywhere you run Envoy. The OPA Envoy plugin is released on the same monthly cadence as the OPA project, like Philip mentioned earlier. So it ensures that you are always able to use the latest features in your policies, regardless of where you're applying them. OPA Envoy is pretty popular. In September, we had over 147,000 image pulls, and it's actively maintained and developed with close to 100 PRs this year. When I talk to users, I consistently hear how much they value the ability to unify policy as code across the stack without having to add service calls to their applications. We see users build it into their software architecture natively. We also see users use it to wrap existing services with modern cloud-native authorization. You can just drop an Envoy proxy in front of a service, route your traffic through it, and suddenly you get the power of OPA without having to change that application itself. Significant improvements have been made this year in resource management, runtime performance, how much memory we use, how many allocations. If you program in Go, you know how much fun managing allocations in high throughput systems can be. We've done a lot of tuning in that. And then also making it easier for you to be able to discover what type of inputs you can send to OPA, to OPA Envoy, for people who aren't as familiar with what the Envoy X.Z protocol looks like natively. So in terms of features, it allows users to transparently authorize both requests from their users as well as service-to-service traffic based off of the full payload of the request, including body, headers, peer certificate information, source IP, and then other connection-level metadata. It supports being embedded both at layer 7 at the application filtering, the application level filtering stage in Envoy, as well as earlier on in the network external authorization filter. So it allows you to manage both connections that can be inspected at the application protocol level, and then perform simpler decisions at the network transport layer. It also supports modification of request and response headers, request and response body, modification of query parameters, other transformation capabilities. When combined with the full OPA feature set, it's a powerful Swiss Army knife for working with policy as code, because all of your favorite features from OPA itself are included: bundles, decision logging, tracing, etc. OK, so roadmap update. Where are we going over the next year? As I mentioned before, we're still actively maintaining and developing the plugin to make sure it stays up to date with the latest features from Envoy. We have some exciting new Envoy features as the Envoy community moves forward that we have to add support for, like the external processing protocol, which gives much more fine-grained transformation capabilities and unlocks easier content filtering, DLP, and API governance features, all of which are key when you're managing LLM traffic. We also want to do a docs refresh. The API gateway landscape has changed a lot since the plugin was first developed, and Envoy has sort of become a lower place, a lower part of the backbone of cloud-native traffic management and communication. And there's sort of a whole ecosystem of other projects that have sprung up around Envoy to make it easy for you to control Envoy. We currently document support for Istio and Envoy itself directly, but we're going to be working on adding documentation and examples for some of the newer gateway projects built around the Kubernetes Gateway API, like K-Gateway, Envoy Gateway, and then Istio's ambient mode as well. We also plan to better document and enhance test coverage around things like the network level X.Z features. And then finally, we've been working to make it easier to use OPA Envoy as a policy decision point for systems using SPIFFE IDs. There are a number of features already that can be repurposed to make OPA Envoy a SPIFFE-based policy decision point. But we've heard user feedback, and we've seen that these are challenging to sort of cobble together and require a deep understanding of both how OPA Envoy makes decisions, how inputs get sent, and also what is in the Envoy X.Z messages themselves. We want to make that easy. We think this is a really important use case, especially with the recent interest in the cloud-native community for using SPIFFE to authorize and authenticate AI agents. So we'll be working to augment the plugin with additional built-ins, patterns, and then documentation as well to make it really, really easy to use OPA Envoy with SPIFFE. Like everything else in the OPA ecosystem, the goal of this plugin, the goal of this project is to make it easy for you to have a unified tool chain for policy as code wherever you're running. We want you to be able to reduce fragmentation and deduplicate effort with one way to run policy. So in that vein, if you have suggestions, ideas, if you want to learn more about the project, please come feel free to talk to me or other of the maintainers. Contributions and new contributors are always welcome. If you're interested, I'm happy to help you figure out how to get started. That's it for me. Let's hand it over to Gatekeeper.
Hello, everyone. For people who joined us later, I am Jaydip Gabani. I am maintainer of Gatekeeper. So brief introduction. Gatekeeper is essentially audit controller and admission controller, which uses Cell and Rego as its policy engine and allows you to define policies. for Kubernetes governance and compliance. So yeah, so let's head into the updates. So since 3.19, we added a new disk driver, which helps you export the audit violations to disk, and it's a workaround to increase your violations reporting throughput, because currently we are using constraint schema, and this improves in the performance of exporting audit violations through disk, because you can do it at scale. And then you can plug in sidecar, or you can spin up your own pods, export the violations into however you want, plug it into your pipelines, and do interesting things with violations. Then we integrated a VAP a while ago, validating admission policies and entry feature for Kubernetes, which allows admission control as well. So we integrated into Gatekeeper a while ago, and now we are moving the integration to beta, which means that any constraint template that has cell engine in it and contains common expression language, its policy logic the Gatekeeper will interpret that and create and manage VAP resources to allow you the benefits of entry KTS feature. We added a new CRD called connection to connection management for connection management to export violations to different backends. We added status and metrics for external data features. External data is basically an external data source that allows you to look up information real time when your policies are being evaluated and enforced at admission time or during the audit. And then we added a bunch of things to make sure that VAP, validating admission resources created by Gatekeeper, has the same enforcement criteria as you already configured through validating admission webhook in Gatekeeper, or a config resource or exemption namespaces flags. So to make sure that whenever a VAP resource is created and an admission is evaluated by Kube API server, the behavior remains the same and you don't get any flaky behaviors. For upcoming in Gatekeeper, we are working on a bunch of stabilization in terms of graduating APIs. External data, as I talked about, is an API that allows you to talk to external data sources. So we are working to push it to GA. Connection is connection management API for exporting violations. We are working to graduate it to beta. And sync set allows you to sync on-cluster resources for admission scenarios like referencing policies, and we are working on to graduating that API to beta as well. And with the VAP integration, there are changes coming in that will stabilize the integration overall, move it to GA, and then for this driver, we are working to get it to beta. That's about it for Gatekeeper. I guess this is the birthday for OPA because it turns 10. Oh yeah, sorry. Yeah, and I think we are with that open for any questions.
Oh, so if there are any questions, there is a mic here in the center of the room so that you'll be heard on the recording. If you shout to me, I can hear you, but I'll have to repeat your question. Okay, so the question was, how do you actually deploy the policy code and bring all that into production? Which is a great question. So OPA has a way to package up policies and that trusted configuration data called bundles. Previously, you had to build your own control plane from scratch to distribute those bundles, but this year, we have had a project called OPA Control Plane that is open sourced, which is under the Open Policy Agent organization, which will handle pulling your code down from Git or some other place, building the bundles, and then we'll push them up to anything that looks vaguely like an S3 bucket or other cloud storage. Your Open Policy Agent instances, when you start them up, can be configured to pull that policy bundle down from the S3 storage, and then it'll set up and go. Does that answer your question? The code, are you asking about the code for, the results of the bundle? So I believe the question here is, where is that trusted configuration data coming from? You provide that. That comes from your infrastructure or some other source, right? Ultimately, if you can get it into JSON or YAML form, you can build the trusted configuration data into your bundles and ship it upstream. Does that work? Very good. Is your question specifically about Kubernetes? Okay.
For Kubernetes, we do have the Gatekeeper project, which is an emission webhook, and it will actually deploy the actual Rego code or cell code as a CRD, right? So once the rules are in the CRDs, when you run them, they're just in memory, right? But they live on the cluster as CRDs. Yeah, hope that helped.
All right.
Thank you. Thank you for the presentation. I have the question similar to what he's asking. So I have built a UI where the policy can be edited. My policy need to be real-time synced with OPA. Syncing from the UI to going to S3 bucket and then OPA server pulling from there doesn't seem very ideal way of doing it. I was thinking loud that maybe if we do a database, something, could be DynamoDB or could be anything where we store the policy and OPA interacts with those databases and use the policies in the real time. As we modify the policy, it affects immediately.
I'm sorry, can you repeat that and maybe get a little closer to the mic?
Okay, so basically the policy I want to implement in the real time, people are modifying the policy, it should be in effect immediately. Syncing with the S3 has their own challenges. I was thinking that maybe if introduce the database where policy can be stored and OPA interacts with the database to read the policies and make the decisions.
I would not be surprised if someone's doing that in the wild already in some form and just hasn't open sourced it. The Open Policy Agent does have an in-memory storage engine that keeps track of all of the policies it has loaded up, as well as all of the data it has loaded up. There is a REST API for it, but it doesn't interact particularly well with the bundle feature, because the goal of packaging your policy and data together with bundles is so you can kind of know what's in there, right? It allows you to have distinct versions of the static configuration data and the policies, so you can later look at your audit logs and figure out exactly what went into making a particular decision. But the database idea is cool. If you're interested in that sort of thing, might be worth checking out the community Slack and the GitHub issues to see if somebody's already proposed something similar. And if so, yeah, see if there's a spot to contribute there.
Are you using the database?
So the discussion here that was happening off the mics is about storing policies and your data in databases instead of in OPA, which I could imagine having a few advantages, but that's not how things work today. If you're interested in that sort of thing, that could be a fun thing to discuss, I think, in the community Slack. Rita, you had something to say there?
Yeah, I can also share like maybe what AKS or Azure and GKE are doing. Obviously, it's a vendor product, but the way that they're doing is basically a data plane, a place where you keep all your built-in policies. And as a user, say I manage a bunch of Kubernetes clusters, I can actually assign these policies to the clusters that I care about. So in that sense, there is a database in the back, right? But that's how you do the management of policies and application assignment. And then the audit results will then get streamed down to the data plane aspect of, like in Azure, we have something called Azure Policy. GKE has something similar. But yeah, you need a backend, right? You need a data plane.
All right. Any other questions? Going once, going twice. All right. Thank y'all.